Here we have L'Hopital's rule. Started off with the definition. If the limit of f of x over g of x produces the indeterminate form 0 over 0, or basically any combination of infinity over infinity, then the limit as x approaches c of f of x over g of x equals the limit as x approaches c of f prime of x over g prime of x. So, if your limit produces 0 over 0 or any form of infinity over infinity, all you have to do is find the derivative and it'll give you the same outcome but a real answer. I'll show you what I mean in example 1. We're given the limit as x approaches 0 of e to the x minus 1 minus x over x. And when you plug in 0 to that, you get 0 over 0, which is an indeterminate form. So, this problem is eligible for L'Hopital's rule. So, when we start that, we get the limit as x approaches 0 of e to the x plus 1 over 1 after we do the derivative. So now that we've done the derivative, we have a more easier form to work with, and when we plug in 0, we actually get 2 over 1, or 2, and that just acts as your answer, all because we did L'Hopital's rule. Let's look at another one, example 2. Here we have the limit as x approaches 0 of sine of 2x over sine of 3x, so it's a trig problem. Again though, we run into an issue when we plug in 0. Sine of 0 is 0, over sine of 0 is 0, so we get 0 over 0, making this another problem eligible for L'Hopital's rule. So what we have to do to fix this problem is we have to find the derivative of both the top and the bottom, and when we do that, we get the limit as x approaches 0 of 2 cosine 2x over 3 cosine 3x, and then we just have to plug in 0 this time, so it's 2 cosine of 0, giving us 2, and 3 cosine of 0, giving us 3. So we're left with 2 over 3, or 2/3, and that is your answer for this problem. Here's another one. Alright, this time they're starting us off with the limit as x approaches infinity of 3x squared minus 2x plus 1 over 2x squared plus 3. When we plug in infinity, it's easy to tell that we have infinity over infinity, which is an indeterminate form. So we start by taking the derivative of both the top and the bottom, and we're left with the limit as x approaches infinity of 6x minus 2 over 4x. But this time, again, we plug in infinity, and again we get infinity over infinity. So L'Hopital's rule didn't work again. What do we have to do? We have to apply L'Hopital's rule again. So, we're going to once more take the derivative of both the top and the bottom and see what happens. When we do that, we get the limit as x approaches infinity of 6 over 4, and the only answer to that is to simplify that to 3 halves, and that would be your answer for that one. So 3 halves is your answer to example 3. And that is L'Hopital's rule.